All right, in this video, we'll be looking at some bonding type questions. In this first one, we got an atom of chlorine and an atom of which of the following elements will form a bond with the most ionic character here. Okay, so we have chlorine, and chlorine is a non-metal. It sits in that top right of the periodic table. And we are looking for something that is most ionic, which means when we want an ionic bond, we need some sort of metal atom to bond with it. So metal plus non-metal makes ionic. Oh, and when it means most, it means it's going to be the most metallic in nature, which means it's going to be farther to the left on the periodic table. Okay, germanium sits on that right side. It's number 32 on the periodic table, and it's in metalloid. It sits in that metalloid area. We've got carbon, which sits in that non-metal area. Copper is a metal. It sits in the transition D block. And we have potassium, which is an alkali metal on the far left of the periodic table. So right off the bat, germanium, carbon are out. Those are non-metal metalloids. They're not truly metals. And we have two other options that are more metallic in nature. Now, comparing the two, potassium actually sits farther on the left compared to copper. Copper's more in the middle. So I'm going to go with potassium D, making it the most ionic in character. We'll form a bond that is ionic. So that's the first one. Number two, which of the following is a non-polar molecule that contains polar bonds? I really like this question. There's two parts to it. We want an overall non-polar molecule and something that contains polar bonds. So polarity is what we're looking at, and we've got CHF3. CHF3 is going to look something like this. We've got CO2 that looks something like this. And we have HCl that looks something like this. And NH3 that looks like this. Okay, so looking at all these options, we want something that's non-polar and has polar bonds. This is a molecule that has polar bonds. The F and the C bonds right here, and the H to the C bonds here, it creates polar bonds. But overall, this is a polar molecule. Okay, it's a polar molecule because we have an asymmetrical shape with this. We have 3 fluorines in the top right here pulling electrons towards it, and 1 H over here. So up here would be partially negatively charged, and up here would be partially positive charged. So this isn't right because it is an overall nonpolar molecule, or it is not a nonpolar molecule. I can see quickly also here we have a polar bond. Everything's getting pulled to the chlorines, and that makes it also a polar molecule. So that wouldn't work either. Looking here, we have polar bonds as well. H is being pulled towards the N right here. These make these polar bonds. But once again, because I have this lone pair right here, I have an overall polar molecule. So that wouldn't be right, which I'm left with CO2 here. Now CO2 does have polar bonds. The oxygen is pulling those electrons closer to them from away from the carbon, making it a polar bond. But it is an overall non-polar molecule. It's symmetrical, and it's getting pulled into those same directions. So B definitely is the right answer there. Look at one more. Which of the following bonds represented in the diagram above is the most polar? Okay, I've got a couple options here. I've got this CCl bond, Ci bond, CH bond, and CBr bond. So ultimately, if I want something that's the most polar, I want something that's pulling on that carbon the strongest. So it's whatever is the most electronegative atom on the periodic table. I can use that by looking at whatever's closest to the top right. In this case, that would be chlorine. So my answer for this one should be CCl. It is the most polar. Ci, CBr are the next two, and CH ultimately is the weakest or the least polar. But it will be A as your answer for that one. And that was the last question.